All right, you guys, so we are going to be talking about the mean absolute deviation, which is also known as MAD. So the steps for identifying this first, you are going to determine the mean of the data, then you're going to make a number line that includes all the data points. So these can be interchangeable, but yes, you want to be determining the mean of the data first. We're then going to make a vertical line through the mean on the number line, and then you're going to plot the deviations, and then you're going to determine the deviation, absolute deviation, and then we're going to determine the sum of the absolute deviation, and we're going to divide by the number of values that there actually are. So I will write all this out and it'll make more sense. For our first section here, we want to actually determine the MAD. So for example, we're going to do number 1. I'll have you guys do number 2, I'll do number 3, and you'll do number 4. So our first step was to determine the mean of the data. So what we're going to do, we're going to determine the mean of the data for these first set of data points. So remember, you are going to add up those values. When we add up those values, we end up getting 12. And then we're also going to, so you guys, this X bar right there, that actually represents the mean. So when we add those all up, we get 12. We divide by the number of values that there actually are, which there are 4, and our mean is going to be 3. So now I'm going to make a number line. 1, 2, 3, 4, 5, 6. And we are going to, so we're making sure that we are including a number line that includes all of our data points. So we have 1 through 6, which means we have included 2 through 4. So now our next step, we're going to make a vertical line through the mean of our actual number line. So our mean is right here. We're making a vertical line through it. And then now we're going to see that our next step is going to plot the deviations. So what we mean by that, if we look at our 2, we see that, so we're going to go from 2. From our mean, our first point was a -1. We're 1 less than our mean. Our second one, we are also 1 less than our mean. Then we go to our third data point, and we're actually +1 from our data. And then our next one, our second point, we are +1. So we are actually trying to even out. So these are actually what we call the deviations. So we are deviating from the mean -1. We are deviating from the mean by +1. So this is our deviations from the mean. So now that we have our deviations, our next step, so we plot the deviations. This is our deviation from the mean, -1. We're deviating from the mean -1 or +1 in this case. Then we need to determine the absolute value. These bars right here, those bars mean absolute value. So remember, oops, if I could spell absolute value right. I'm not sure if you guys remember this, but the absolute value means all of the positive values. So what we are going to do, we're going to take the positive values. So if we take the absolute value of -1, that actually equals 1. If we take the absolute value of 1, that also equals 1. So we are going to determine the deviations. So that means we have a +1, a +1, 2, 3, and 4. So what this little symbol right here, that little E kind of looking thing, means you're taking the sum of our deviations. So we just took the absolute value of all of our numbers, and they all equal 1. We have 4 of our deviations, so that's 4 ones. So if we add those all up, so I'm going to show you, we have 1 plus 1 plus 1 plus 1. That's going to equal 4. That's our sum of our deviations. Now we are going to divide by the number of data values. And I'm going to say even deviation values. So there are 4 of them. So 4 divided by 4 means that our MAD, and you can abbreviate those, we had 4 divided by 4, that is equal to 1. So our standard deviation, or our MAD mean absolute deviation is 1 in this case. Go ahead and try and do number 2. I'm going to do number 3. So again, we are going to take the mean of our data. This x bar represents the mean. Let me actually write that up here too. X bar represents the mean of our data. So now I'm going to do 3 plus 3 plus 4 plus 7 plus 8. When I actually add that in my calculator, I get 28. I'm going to divide by the number of data values I have, 1, 2, 3, 4, 5. And I end up getting 28 divided by, sorry, this is not 28. I only have 2 3s. So I should actually subtract, added that I had this problem with number 3 on me. So 25, I should be my value. 25 divided by 5, we get 5. This is my mean. So now my next step is to draw that number line. That's going to include all of my values. So I have to start off with 3, making sure that I include it. I have to go all the way up to number 8. Okay, so now that I have drawn my number line, I now need to make a vertical line through the mean. My mean was 5, so I'm making my vertical line through the mean. Now I'm going to plot my deviations. So starting off with 3, this was -2 deviations away from the mean. My second point was -2 deviations from the mean. Then I go to 4. My third point was -1 deviations from the mean. My next point is actually +2 deviations. The next one is 3 deviations, and the reason I'm going to do it in the middle over here, because look it, we had 2 that evened out. Our 3 was actually with these 3. Okay, so now we are going to calculate, add up all of our absolute values. So we have our M.A.D. Let's write it down here. So I have 1 plus 2 plus 2 plus 3 plus 2. When I add those all up, I get 10. Then we're going to divide by the number of values that we actually had. Again, it should be the same number you divided by your mean, divided by 5 here, and we get 2. So our mean absolute deviation from the mean, from the mean is 2. Okay. Now go ahead and try number 4. You guys are doing this on your own. Try it, and I will check in class with you guys next time I see you on your own. And we are going to do one of our tables here. So we are determining the M.A.D with our table. So this is just a way to kind of organize our work, a different way to do this. So we have the data points 1, 2, 3, 4, and 5. I'm going to define what each of these actually mean here. So this right here, these are the data points. I'm going to put 1, 2, 3, 4, and 5. Those are my data points. I just got them. What this means, this is our data points minus our mean. This is the mean. So let's determine our mean. So we're going to do the x bar. We're going to do 1 plus 2 plus 3 plus 4 plus 5. We end up getting our mean to add up to 15. We're dividing by the total number that there are, and we get a mean of 3. Okay, let me back up so you guys can see that. So now we have 3 there. Now I'm going to take this data point and I'm going to subtract it. So 1 minus my mean of 3 equals -2. 2 minus 3 equals -1. 3 minus 3 equals 0. 4 minus 3 equals 1. And 5 minus 3 equals 2. Now we're going to take the absolute value of these, so this is the absolute value of the values over here. Okay, so now the absolute value of -2 is equal to 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Now remember this little symbol right here means the sum. The sum. Hopefully you guys can see that. I don't know if you can. This says the sum. Okay, and that's also going to be the sum right here. So once we take the sum of these values here, we should actually be zeroing out. So -2, this is -3, plus 0 is still -3, plus 1 is -2, and then plus +2 is actually 0. So that's just the sum of these values. Now if we take the sum of these values, we see 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 2 is 6. Okay, now we are going to take the mean absolute deviation by taking that sum from our value of this one and dividing by the number of values that we actually had. So that is our, remember we divide by 5 there, so this is our final solution here. Our fraction we cannot simplify. If you want to leave it as a mixed number, remember you divide, how many times does 5 go into 6 nicely? 1 time. 6 minus 5, our remainder stays on top of 1, and your denominator always stays the same. So we have a 1 1/5 of our deviation. To show you what that picture looks like, you guys, so we already figured out the mean of 3. We need to draw a number line to make sure that we include all of our data points. I'll just add 6, and then we're going to draw a vertical line directly in our mean, and we're going to see how much far they deviate from. So remember that this was the -2. That's where our -2 came from. We were subtracting it from the mean. Now we're going to go to the data point of 2, which was -1 deviations away. Oh, look, we got the -1 there. Yay. And then 0, we actually just have a point. Our third point is actually 0. We don't have a deviation from the mean. It actually is the mean. Our data point is the mean at 3. Our next deviation point was at 4, so I'm going to go to my next one at +1. Yay, we got a +1 there. And then my next one that I have is going to be all the way to number 5. That was +2, and we end up seeing that the deviation from the mean was 2. So it's the difference basically when we're subtracting these. So that's what it looks like in the table. This is what it looks like on the actual diagram. Okay, and then remember when we were adding all these up, so when we add all these up, remember they end up canceling each other out. That's why it ended up being 0 here. They were even. When we're taking the absolute values, we added up 1 plus 2 plus 1 plus 2. That's what we ended up doing here. We took the absolute value and got 6 there. And then we just divided by the values of our number of data points in our data set. All right, you guys, go ahead and try number 6. This is the one you will try. I will check in class. Is it for our notes today. Have a good day.